This is Gail Kovac for Gresham Barlow School District, Summer School, High School Credit Recovery, Data Reasoning, and Learning Target number 9. I can identify the relationship and correlation of a scatter plot. So far we've only looked at univariate data, which is one variable, and you can make dot plots, histograms, box plots from that. And now we are looking at bivariate data. So this is still quantitative data, the data that comes in a numeric form, but now we are comparing one variable to another, such as height versus weight, hours and pay, something like that. Both of them come as a quantity, as a number, and you can compare the two of them together. So when we create a dot plot that compares two variables together, we get what we call a scatter plot, where you have all sorts of dots that are scattered along a XY coordinate plane, and they have both a value for the X and value for the Y. So for example, there is this little dot right down here, I want to say, and its X value, I believe, is like maybe about 8.5 if you look here on whatever this axis is, whatever the variable is there. So it's about 8.5 value there, and it's just a little under 3. Yeah, a little under 3 for this variable. So now each point comes with 2 numbers. And what we would like to do is when we graph lots of these data points, lots of these individual observations, what do we see as the connection between these two? So if you look at this first graph, it looks like I see that as the values in the X increase, the values of the Y also tend to, on average, increase. And that's because you see this sort of upward-ish linear motion like this. So as X increases, Y also increases. The graph goes up from left to right. So we call that having a positive relationship. If the graph were to go downwards from left to right, we call that negative. If the dots are kind of everywhere and they're scattered all over and you kind of can't see a definitive like upward or downward motion, then that would be no relationship. So since this goes up, this is a positive relationship. And correlation is how well do those two variables correlate together along a trend. And we're looking at a line here. So either the correlation is really strong, like those points are really tight together in that linear form, or maybe there's some that are a little bit more spread out and it's kind of weak, or maybe it's just scattered everywhere and there is no correlation at all. So let's take a look here. It looks like I definitely see the line going up, and there's lots of strong points specifically here, but then I've got a few little weirdos over here as well. These could potentially be outliers. This makes the relationship not quite as strong as it could be. So we're going to say this does have a positive correlation, but it's a little bit weaker because those points aren't super, super tight together, kind of like they are at the bottom here. Now let's go on to the next one. In this case, I see definitely a relationship between the two. And as the values of the X go up, the values of the Y tend to go down now instead. And gosh, those points are really tight together. Even this one at the end down here, it's really tight together. So this is a negative relationship. And since I don't really have any sort of like weirdo points that are way off, I'm going to call this a really strong correlation. I mean, it's practically a straight line. I've got a few that are like a little bit off, but not much at all. So that's a pretty strong correlation. So graph goes up from left to right, it's a positive relationship. If it goes down, we call that negative. And if the dots are kind of just scattered everywhere as like no real pattern that you can see, that would be no relationship. Correlation is how tight are those points together in that pattern? Are they very strong, tight together? Do you have some that kind of pull away to make the correlation a little bit weaker? Or is it just so scattered that you don't see any correlation at all? This is for bivariate numeric data.